Welcome to Grade 12 Physics AP, Mastering Free Body Diagram in Minutes. In this video, I am going to go over solving free body diagram problems. Again, let's review the basic steps in solving these free body diagram problems. So you first draw the objects as blocks, and if it's on a surface, whether or not it is flat or on an incline, it is best to draw the surface as well. Then draw and label all the forces acted upon the object, such as the forces that I mentioned in my last video, especially if it's on the surface or any surface. Don't forget to put normal force as well. Now write two equations, one summarizing all the forces acting in the x-axis and another one in the y-axis. Be sure that you get the directions correct. It doesn't matter which way in these cases. However, if it's acting in the opposite direction, then one needs to be in the positive side and the other one is in the negative side. So after you got these equations, then you could solve for the variables using algebra to find the forces that you need for the problem. So let's go over an example. I might create other examples in other videos, just if I see fit that it might help you guys in acing your exams. So let's look at this example. A 10 kilogram box is hung by two ropes. One makes 50 degrees with the ceiling and the other one is 20 degrees. What are the tensions in these two ropes? So the first step is to draw and label, and as you can see, our object is drawn as a block, and that there is a force that's going down, which is the gravitational force. The object is 10 kilograms, so you know that the force would be the 10 kilograms times the acceleration of gravity, which is it's 9.81 meters per second square. But in a lot of cases, when you state the assumption that it is 10 meters per second square, it simples the math, and they would actually let you to do it. Of course, if it's a multiple choice, then it is best for you to put 9.81 just to have more accurate results. Now, if you've remembered your trig, you know that the angle that you make from the ceiling would equate to the angle that the tension of the rope makes with respect to the object. It's a trigonometry property. So as you can see, the T1 or tension 1 makes 50 degrees and tension 2 makes the 20 degrees. So now let's write the two equations, the one in the x-axis and the one in the y-axis. From the x-axis, we take again in trigonometry, you would know that the x component would need to have the T1 x portion to equal to the T2 x portion, or else the object would actually move from would accelerate into a particular direction, and we don't want that because this is an equilibrium problem. So in this case, our equation can be T1 cosine 50 degrees equals to T2 cosine 20 degrees. And if you wanted to let's say put this into a summation formula, it'll be T1 cosine 50 degrees plus T2 cosine 20 degrees equals to 0, in which your T2 would then, or T1 would then be, either one of them would be a negative value. It doesn't really matter as long as you get your directions straight. You could get this value, and you could use common sense to determine which direction it is. So in this case, I'm just going to go in using the other way instead of the way that I teach you before, just so that you could know that there are more than one ways to do it, and we could use common sense to ensure that we get the directions of the tensions correct. Now for the y direction, we know that the summation of the y components of T1 and T2 would equate to the gravitational force that is of the object, which we said is 10 kilograms times the acceleration of gravity, which is, we have the assumption, I know it's 9.81, but we assume in this case it's 10 to simplify it, so we got 100 newtons in this case. So now let's solve this equation. So we know that T1 cosine 50 equals to T2 cosine 20 degrees, which equates to, when you solve the cosines, you would have 0.6428 T1 equals to 0.94 T2. And here you could see that T1 would equate to 1.46 of T2. Remember this, and then we would then look at our equation number 2. So let's look at equation number 2. T1 sine 50 degrees plus T2 sine 20 degrees equals to 100 newtons. And if we solve for that, we got 0.766 T1 plus 0.342 T2 equals to 100 newtons. So if we substitute what we got from equation 1 into here, substitute that 1.46 T2 into all of the T1s that we see in this equation, which only has one occurrence, we would have 0.766 times 1.46 T2 plus 0.342 T2 equals 100 newtons. So in this case, somehow the math works, and it equates to 1.46 T2 equals 100 newtons. So if we to solve T2, we would have 100 newtons divided by 1.46, and we would get 68.49 newtons. Likewise, if we plug 68.49 newtons back into our equation 1, which is T1 equals to 1.46 times T2, or 68.49 newtons, we'll get back 100 newtons. So in with regards here, we have resolved both the tension for T1 and T2. And thank you for listening to our video. This concludes the lecture. If you are interested in more studying materials, please download our physics app and other AP course study apps. This can be found in the links in our video description through YouTube. Also, if you want to keep up to date with our latest videos for studying purposes, please subscribe to our YouTube channel, and please share our videos via Twitter and Facebook. Thank you.